Hi, I'm Ken Miller,
And I'm David Erdos.
and welcome to the Erdos Miller New Technology Podcast. Today's topic is about downlinks. David, we have a couple firsts today.
Yep, what's that?
First video podcast, so that's
Yeah.
new for us. So this is the start of season 2. We're going to be doing it on video and audio from now on. You can check out season 1, that's on iTunes and Spotify now, so just search for Erdos Miller. We also have the YouTube videos coming. And then also we have a sponsor for season 2. So Gibson Reports is sponsoring us for season 2. They provide excellent NWD and directional drilling market share reports. So if you want to know, where your company stands or which companies are on top or which ones are getting losing market share, then check out Gibson Reports, right?
Yeah.
So GibsonReports.com. So Dave, I got a call from one of our favorite potential customers.
Yeah.
We have to talk about one of my favorite topics, which is downlinking.
In terms of what? MWD downlinking?
Absolutely.
Okay.
So for everyone who's not familiar, why don't you explain what a downlink is?
Yeah, so with MWD, we're mostly focused on sending data uphole from downhole.
Right.
And so that's an uplink. And so downlink is the opposite, sending data from uphole to downhole.
Okay. That seems like not what we want to do. That seems like
It's
the
not-
opposites.
Yeah, it's not usually what you want to do, but sometimes it's very handy to
So
be able to
what-
send some data downhole.
Well, why? Why would we ever want to do that, right? We're trying to figure out where we're drilling, what's down there. Why would we
Yeah.
ever need to tell, why do I need to tell the rocks what's going on up here, right? So,
Yeah, so it actually becomes useful because sometimes we want to change some operational mode or parameters of the telemetry of the downhole tool. And so we might need to change some of the telemetry settings in order to get better reception uphole.
oh, okay. So we're not trying to tell the rocks what we're having for lunch,
Right.
right? We're trying to tell our tools that are down there operating to do something different
Yeah.
that they can't quite make a decision on their own, right?
Exactly.
Okay, that's cool.
So we kind of close the loop and say, hey, we can't hear you.
Right.
Downhole tool, talk louder or slower.
Okay, and we use that term close the loop because we're sending data up and now we're sending data back down, and so
Exactly.
now that's a loop, right? Okay.
Exactly.
So what are some things we would want to downlink to change that tool?
So when we're talking about a mud pulse tool, we might downlink to change the pulse width, or we might send up different sequences and data in the curve or the lateral or the vertical. And similarly with an EM tool, we might change the power output or the frequency and any other telemetry patterns. And I actually did some calculations and we typically say we transmit at maybe 1 bit per second or 2 to 3.
Uphole, right?
Uphole, going from downhole to up.
NWD data rate, right?
Yeah, and so the downlink data rate
I
is
don't even want to know.
it's like less than 0.05 bits per second, maybe 0.01 depending on.
So smoke signals may literally be faster.
Yes.
Okay.
I think they would be actually.
Okay. That's impressive. Like that's
Yeah.
impressively slow. Well, I'm glad we don't have to deal with that for our uplink, right?
Yeah.
Okay. So how do we do this? Is it just magic? I just think, okay, tool, I want you to do something differently. How do we actually pull this off?
Yeah, I wish we could just think and it act. But
Yeah.
for mud pulse downlink, you typically can so you turn the pumps on and off, and because the
Okay.
downhole tool can sense when the pumps are on and off, either based off of pressure or vibration. And so if we turn the pumps on for say 60 seconds, off for 60 seconds, on for another 60 seconds, and in some pre-configured pattern, the downhole tool can detect that and you can send a message to it, say
So-
change mode.
We have a predetermined pattern of smoke signal here,
Yeah,
and our smoke signal is turning the pumps on and off in this case.
exactly.
Okay. Is that the only way to do it?
Nope. Another common way is based off rotation.
Okay.
And so we can turn the top drive on and off, and so the tool senses
Or a high RPM to a
Yeah,
low
yeah,
RPM, right?
low to
Some
high.
sort of difference, right?
below and above
What
some
we need, right?
threshold. Yeah, so you might go from 30 to 60 RPM for 30 seconds, and then back, and so on, once again in some predefined pattern,
Yep.
and send the data.
Okay.
And for an EM tool, what you do is you basically stick 2 big rods in the ground, and you just dump a bunch of current and power into the ground.
Okay.
And the EM tool has a receiver where it measures the voltage difference across.
So that's similar how the EM tool transmits in the first place.
Yeah, so
Okay.
it's the exact opposite, except on surface you have way more power you can dump into the ground. So that's
okay.
nice.
A little easier, right?
Yeah, you're not limited to whatever your batteries can provide. You got big
Okay.
generators to power everything.
That's fun. So are downlinks only useful for NWD systems?
No. So downlinks are actually useful for rotary steerables or for smart tools like agitators.
Yeah. I don't know if there's any smart agitators yet, but
Not yet.
there could be, right?
There could be.
Yeah.
It's possible.
Yeah.
And
So-
you might tell an RSS, hold this inclination or this azimuth, or any other number of parameters.
Okay. So any kind of tool that needs to be instructed to do something differently, right? So the RSS, you might change how it's holding inclination or azimuth, right, or change its build rate or something, and then you could potentially build like a smart agitator that like turned on and off, right?
Yeah.
With the downlink, some sort of downlink, right? Any sort of like there's tools that could be opening valves or ports downhole.
Yeah,
And this could
exactly.
be not just used in drilling, but in completions as well, right? I mean, this
Absolutely.
is just a way of signaling to underground systems. So if you have, I don't know that you can really rotate into completions, but I'm sure you can figure out some other way
Yeah.
to do it, right? Turning pumps on and off and talking to devices that are down there.
Yeah.
Well, I think in completions they like to use the ball drops, right? I mean,
Yeah.
there's some of the ones that are newer that are kind of RFID or whatever, right? And so that's another form of downlinking, right?
Yes.
Okay. Those RFID kind of balls. Okay.
So let me turn the tables on you.
Okay.
So why don't we use downlinks all the time? It sounds really useful.
Couple reasons. One, you just described that bit rate, right? 0.05, was that what I heard?
Yeah, or
bits
less.
per second?
Probably less most of the time.
Right, so if I wanted to send 5 bits, that's what, I'm going to do math here live, and it's 1,000 seconds, 100 seconds? What's the number?
Yeah.
Yeah, something like that. It's a
Large number of
A large
seconds.
number of seconds to get that done, right? Well, seconds on a drilling rig are really expensive.
Yeah.
Okay, so when we're doing these manual multi-minute downlinks, that's non-productive time, right?
Yeah.
We don't really want that, right? So we're at the very first we're going to minimize how often we have to do that, just because it's costly to do it, right? We can't just do it for fun, right? Nobody wants to shut down a rig just to try something, unfortunately. So that's number one. Number two is they can sometimes be unreliable. Sometimes they're a little hard to figure out exactly how to make the smoke signal. And then also, it's not a perfect system, right? The drill pipe, ends up being very flexible. So like if you have a rotation downlink, you could be putting in like a really clear signal at the surface, but the fact that there's so much torque in the system and the drill pipe is so long that it might not be spinning as evenly at the bit as it is, when you're spinning it on the surface, right? And so you might attempt to downlink and it might look great from what you saw on the surface, but the tool might still miss it, not because of the tool's fault, but because you've got some weird, kind of torquey stuff going on with your drill pipe, right? And it's got, rotational waves that are being reflected, right? So these tools are still so far away from us that we still have transmission errors, right? And then we sometimes, miss these downlinks, right? And so when you combine the fact that they already take a long time, right? And nobody really wants to do them unless they have to, on top of the fact that they often have transmission errors, that's a rough combination, because you might have to try it 2 or 3 times, and so like a 5-minute downlink becomes a 15-minute downlink because you had to do it 3 times, and now we're measuring our non-productive time in serious fractions of an hour, and so someone's going to get pretty grumpy about that, right? Anyways, there's your answer.
Yeah. And so the way we've talked about downlinks now, we've been talking about it in a fairly manual way, like manually turning pumps on and off. Can this be automated?
Absolutely, right? So, you can automate all 3 of these types of downlinks. The easiest one to automate is the EM, right? Because it's almost automated from the beginning, right? Because it sends out an EM signal and the computer has to control that, right? And so with EM tools, the downlinks are wonderful because it's just a 1-button press and off it goes, right? And so it might send out a 2 or 3 minute pattern to do it, but the machine's doing it and your hands off, right? So that's great. And it doesn't require the rig to stop usually to get it done, right? So that's great because it eliminates the non-productive time. And it's usually a lot more successful, right? So then the only limitation there is what formations can you get those downlinks through, right? I know a lot of the bigger companies, like the majors, have actually automated the mud pulse downlinking. And so what they'll do is they'll build these big skids kind of things that sit next to the rig, and you'll pass all of the standpipe flow from the pumps to the rig through that skid. And then what they'll have is they'll have a hose or some sort of port that bleeds off into the pits. And they'll actually have a valve and a computer on there that control that bleed off valve, and they'll use that for timing to send the automated mud pulse downlinks, right? And so that's cool. Pretty pricey. It's a really big piece of equipment, right? It's like, I don't know, car size kind of usually. I don't know, motorbike sized. It's a pretty big piece of equipment. It takes a lot of equipment to divert that amount of flow safely and reliably, and it's a lot to hook up, right?
Right.
And then I think the ones that can actually be automated really easily from now on are the rotary downlinks, right? Because there's a lot of things that are coming out in the industry like this Novos operating system from NOV, and it's becoming easier every day to kind of run your own code on the rigs, if you will. And so it's totally possible, I think, to now control the top drives in a programmatic fashion to automate those RPM downlinks, right? So you could give the top drive computer or the rig computer a pattern you want to do, and it'll do it automatically on the top drive. And it may even be possible to do it while drilling. I don't know that it's impossible that if you're trying to drill ahead at 60 RPM, if the computer kind of nudges you up between 65 and 55 to impart the pattern to the tool, that might work, right? You might still kind of average 60 RPM as far as the bit down hole is concerned, but the tool might be able to see that while you're drilling, right, and be able to do an automated RPM downlink even while you're drilling ahead. That's kind of a wild proposition, but that's possible.
Without any significant impact on your drilling ROP and all that.
Right. So, but if you want the best automation, EM downlink is your go-to.
Yeah. Okay. So, what else can we expect in the future?
Well, I'd love to see some new type of a fourth category of downlinking technology. I know there's like the RFID balls, but I'm sure somebody can figure out some other way to do it. And then the big thing I'm looking forward to is more closed loop NWD systems, right? To where the downlinking is not a let's do this only if we have to, but where it's part of the system and the system really uses it to its advantage, right? And so I think that you're going to see a lot more groups coming out with a lot more sophisticated of the EM downlinks, and those are going to be targeting the NWD systems and the rotary steerable systems. And so you're going to have a computer running on surface where it's constantly monitoring what the tool is doing and then deciding on its own whether or not to tell the tool to do something different, right? So a big thing would be on the EM tools, right? So the EM tools could easily look at the power that they're receiving on surface, how big the signal to noise ratio is, and say, okay, well, I'm using way too much battery power because the signal is really clear. So you know what, I can back off a little bit and save the power on the batteries down hole and go for longer. And so I'll send an automated downlink telling it to turn the power down, right? Or it'll be, the signal's too weak, I keep getting errors. So that the downlink system will automatically send the message and say, okay, turn the power up, and do kind of automated power management of the EM transmission that way, right? Or just automatically tell the tool what the rig's doing, right? So that it can make better decisions like that. So once we get that closed loop kind of operating more regularly, the sky's the limit. You kind of reach a new level or plateau that you can go to with these kind of drilling systems.
Yeah, wow, that sounds really cool. All right, well, that's all the time we have for today's show.
I'm Ken Miller.
And I'm David Erdos.
And this has been another episode of the Erdos Miller New Technology Podcast. If you have questions for Dave and Ken, please write podcast@erdosmiller.com. We might put them in the show.